We're going to do a couple of the practice problems together, just hopefully get you squared away a little bit more here. The rules again are at the top. They're also on the previous page, but let's take a look at number 5. Pretty straightforward most of these are, and they don't take very long, assuming you know what it is you're supposed to be doing. They only take a couple of seconds. So y to the negative 15th. Remember, you can make anything into a fraction, guys, because really with the negative exponents, we're trying to move things within a fraction. So if it's not a fraction and you think it'll help, you can just make it a fraction. But anything with a negative exponent gets moved. So essentially, since we just made it a fraction, since y to the negative 15th is in the numerator, we need to move it to the denominator to be positive. We still need it to be a fraction. Remember, adding 1 to anything doesn't change the value. So 1 over y to the 15th. So 6 is just the opposite. X to the negative 15th is in the bottom, so we're going to move it to the top. X to the 15th would be fine. You can leave it as over 1 if you want, but this would really just become x to the 15th. Number 9, I try to do a cross if I can first, and then worry about the numerator and denominator, like subtracting exponents. So if we multiply across, remember when we multiply, n to the 4th times n to the 6th will give us n to the 10th. And again on the bottom, n to the 8th times n squared is n to the 10th. So we end up with something over itself, which is equal to the value of 1, right? But we also know that when we divide, we subtract. So this is where 10 minus 10 is 0. Anything to the 0 power, that's just enforcing that idea that it equals 1. V to the over 3 to the 4th times 5 over v squared. I like to distribute my exponents inside to everything first. So this will become v to the 4th, 3 to the 4th, times 5 squared over v squared. So yes, it's two separate fractions, but you're still going to multiply straight across. So 5 squared times v to the 4th is 25v to the 4th. 3 to the 4th times v squared is 81. I do multiply those number values out. 25 over 84 does not reduce, but v to the 4th over v squared, you just subtract. 4 minus 2 is 2. So 25v squared over 81. (13), same thing. I like to distribute that exponent in there to everything. So 2 to the negative 1st over x to the negative 1st. In this case, they both have a negative exponent. They both need to be moved. So what's going to happen is x is going to come to the top and have now a positive exponent, and 2 will go to the bottom and have a positive exponent. Again, you don't really need that power of 1, but it can't be a negative power of 1. So they did both need switched. We'll leave the exponent there. So just do it one sort of piece at a time. That's kind of a general idea of how I usually do it. So I usually always distribute the powers in. Then if there's more than one fraction, I do try to multiply across those numerators and denominators to make it a single fraction. Then I reduce the like terms within that single fraction you have left. So let's do just a couple more. Excuse me. And then you guys can try the rest. So 16, it is a single fraction. There's no powers to distribute. So I'm going to go ahead and multiply this denominator. So this becomes 8d still on the top, over 10 times 9 is 90. D to the negative fourth times d squared is d to the negative 2. So, it doesn't have a power, so it's really d to the first on the top. When reducing, you subtract the exponents, right? So don't let the negatives trip you up. This is you subtract from top to bottom. So this is 1 minus negative 2. Well, what's a minus and negative become? Plus. So this really becomes d cubed on the top, and we can reduce 80 and 90 by 2 and get 4 over 45. So do know your exponent rules, but also don't let the negatives, subtracting those negatives, trip you guys up. $22, I'm going to distribute the negative to my numerator and denominator. So this will now be x to the fourth over xz to the fourth. And then I'm going to distribute that power inside there. So x to the fourth over x to the fourth, z to the fourth. So 4 minus 4 is 0. So that really just becomes 1. And remember, anything over itself is 1. And then z to the fourth, since there's no other z's to combine it, stays on the bottom there. So let's try 27. Again, that power on the outside I'll take care of first. So to everything inside. So this will now be x to the 12th, b to the 3rd, 4 to the negative 3rd. Remember, if there is no power, it's really a 1. Times 2x to the 5th. If you want to put that over 1, if that's helpful to you guys, go for it. So now I'll multiply straight across. So we still have 2. X to the 5th times x to the 12th is now x to the 17th. B cubed. And this would technically be over for 4 to the negative 3rd. But because that's negative, it really needs to come up to the top with everything else. So in this case, we'll actually not have a denominator unless you want to leave it as 1. And then just multiply everything. So 4 to the 3rd is 64, and 64 times 2 is 128. X to the 17th, b cubed. So just, some of you may be able to sort of look at it and do the steps in your head, but I like to sort of just write out each step as we're doing it. And then let's do 28. Again, that cubed power on the outside to the a, the b, and the x. So this will become a cubed, b cubed over x cubed. If you want to keep that first one as a fraction, go ahead and put it over 1. The negative 4 is going to go in there to everything. So a to the negative 36, b to the positive 8, c to the negative 4. Okay, so what we can do here is multiply straight across now to get your single fraction. So a to the negative 36 times a cubed gives you a to the negative 33rd, b to the 8th, b to the 3rd, b to the 11th. And then c, there's nothing to combine with that other c, so it's going to stay c to the negative 4th over x cubed. So when you get this single fraction, the last thing you want to do is just double check, do you have any negative exponents that need moved? We've already combined the like terms, but a and c are negative. So the only thing on the top that's staying is b to the 11th. A is getting moved, x cubed is already down there, and then c now to the positive 4th. As soon as you move that term or that variable, the reason you do that is because then it will have a positive exponent. So as soon as you do that, it's really just the inverse operation and it becomes a positive exponent. So go ahead and try the rest.